And can you hear me okay? Okay, great. Okay, so Alicia asked about example 2. So I'm going to bring example 2 up on screen. Like I said, I hope I'm going to be switching back and forth on everything. And this is in section 6.3, example 2, and it kind of covers everything, every type of problem. And I also have examples prepared, so we can also look at that. So let me switch to the problem. Hold on a second. I'm going to share my screen. And okay, this is example 2. Okay, so example 2 is percent of female wage and salary workers who are paid hourly rates for the years 1979 and 1992. Okay, so this is example 2, 6.3, but you can do this for any problem. Okay, so we're going to go through all the steps, but we can do this for any of the problems in the homework. So what you're going to do is you can just copy this table. You see how I'm copying it? I just hold down my mouse and I scroll up. I can copy that whole table and paste it in Excel. So let me switch to Excel. And I pasted that into Excel. So that's just copying and pasting. Let me see. Let me go back and make sure you don't have any questions on that. Okay. I can't see your chat, so while I'm doing this Excel, I'm just going to step through it slowly, and then I'll get to your questions, okay? Because otherwise it's just going to kind of be messy. I don't want to be too messy. All right, so I copied that and pasted that table right in Excel. So what I'm going to do is just select, I hold down my mouse and I select the numbers that I want, and then I'm going to come over here and I'm going to go Insert, and see the recommended charts. I'm on the top now. I go Insert, and there right here is a scatter plot. So I'm going to just press that, and I want the scatter plot. I mean, your Excel might look a little different, but you still just go to the Insert tab and insert a chart, and we go to the scatter plot. So it's just automatically, just a second, please. It should have taken us. There we go. So insert that chart. So it kind of looks linear. It doesn't look too strong. I mean, we have points here, but notice all the years are at the bottom and all the percents are on the side. So my year is X and my percent is Y. So it kind of looks like linear. And then if I just go over here to this plus sign, okay, so I'm going to take plus, and I go to trend line, and I want the trend line, and it automatically draws the line. So I just go to the plus sign in Excel, I go to trend line, check that on, and then automatically there's your line. So that takes care of drawing your linear or your regression line. Then you go over to this arrow, and we have linear. That's the one we want. Notice there's other types, but we want linear. So we go to more options over here. So I'm just going to click that on. And if you look at the bottom of the more options, and look at all the, we're only learning about lines, but you can have all different shapes that you fit these points to, and you want to find the best fit. So again, in this class, we're only learning about lines or linear, straight lines. Okay, now look down here under the more options, and you can display the equation. So there's your line equation right there. And the number in front of the X is your slope, and the number in front without the x is your intercept. Okay, so again, the number in front of x is your slope, and the number on the outside without the x is your intercept. And then it displays r squared. So automatically it finds r squared, the coefficient of determination. So you don't have to do any work there. So again, you just go to the plus sign, trend line, more options. And you go to the bottom of that, and you can display the equation and the r squared value. Okay, now what's r? Well, I get my calculator out, or I can use Excel. R is, so I could just say, equals the square root of 0.8926. Or I just take the square root of it. So that's, I'm just going to label it here, r. That's how I find r. I just take the square root of r squared. Okay, here's r squared. So to get rid of that squared, I take the square root. So in order to do that, I just say, look on top right here. That's the formula bar. I'm on top right here. I can just type SQRT. That means square root of r squared, which is 0.8926. Okay, so that gives me my coefficient, correlation coefficient, or they also call that the Pearson correlation coefficient. Okay, now, so far, that is everything that is A through D on this example. Okay, so I'm going to get out of here. Let me save this and see if you have any questions. Okay, so save. Okay, so I saved that. Let me put it down. Let me go back to the whiteboard. Okay, so let me chat do you have any questions on that? No, okay. Okay, so we know, through Excel, we know the equation of the line, we know r squared, and we know r. Or you could just use a regular calculator to find r by taking the square root of what Excel tells you. Okay, so what does that all tell you? All right, let's see. The next question is E. It says, what do we do for 1991? Okay, so let me go. Let's use the whiteboard. We know y is 0.1656x minus 266.886. Okay, so part E, and again, this is still example 2, is what is the percent in 1991? What's the percent of female wages? So all we do is stick 1991 in there. So 0.1656 1991 minus 266.886, and that came out to 62.82. I'll just round it, 62.82. And you do the same thing for, let's see, 1988. Okay, so 1988, you just plug it in there. So that's using that line to predict. And we use the year in these cases because if you remember the Excel chart, remember we just copied and pasted the years. So you can just plug the year in because that's what we use for our X's. We used the 1979, 1980. We use those for prediction. Now, the only reason you can do that is because those numbers are within our domain. And what does domain mean? Our domain means that our years on that chart went from 1979 to 1992. And 1991 is in there. And 1988 is, I'm sorry, excuse me. Those 2 years are inside of this interval. So it's okay to do that because we use that line to predict those values. Okay, so F was plot the least squares line. We did that. That's what that means. You do that in Excel. It's just the trend line is the same as the least square line or the line of regression. It's all the same thing. Now we want to know, is there a linear relationship between the year and the percent of female wage and salary earners? Okay, well, I missed a question if you noticed, and the question was, is R significant? So let's get to that. So our question is R, the correlation coefficient, significant? Okay, and there's 2 ways to figure that out. One, we use that Pearson calculator. Okay, we have to use technology because all these values come from higher math, which is beyond the course of this, beyond the scope of this course. Sorry, I said that word and I wrote it, but I meant calculator. The Pearson calculator. I'm going to do both ways, or if R is between the critical values, then it's not significant in the table. And I'll draw a picture of that. So it has to be outside plus and minus critical values in the table. So we can do either one. You don't have to do both. You do either one. So I am going to show you both, but you can pick which one you want. And some of the problems just ask you for the critical values. So to do this, again, I'm going to have to switch. So I hope I don't lose you, but I'm going to switch to the Pearson calculator. So let me do that. So I want to share my screen. Share. I'm going to go to the calculator. Okay, this is the calculator link. You can find any calculator online. It's called the Pearson calculator, but this is the one I like to use. We do get ads in it, as you see. But we know this is going to tell us if R is significant. And I'll draw a picture in a minute. But right now, we know R in this same problem is 0.9448 if we rounded it. And we had, how many pieces of data? We had 11. Okay, so N is the number of years in our table, and we had 11 years. So we're going to go to 0.05. We always pretty much use that. Go to calculate. And our P is so small, it's less than our 0.05. Okay, so P, this negative 0.05 means you move the decimal point 5 places to the left. So I'll show you that in a minute when I go to the whiteboard. So I have 1.2 e to the negative 0.05. I'll explain what that means, but we know P is less than 0.05. So again, let's go back to chapter 5 or week 5, and week 5 says P low, null, go. Okay, the null in these problems is where the P is equal to 0. Okay, well, we don't want it equal to 0. We want, remember, if r is close to 1 or -1, then it's a line. It's perfect correlation. So we want r as close as we can to 1 or -1. So let me take us back to the whiteboard. Okay, I know there's a lot here. Question. Okay, here's a question. I can't see the p-value. Oh. Okay, let me go back. Let me go back. It's right here at the bottom. You see that? 1.2e, in blue, it's in blue. It says the result's significant. I want to explain what that means right now, is what I'm doing. Okay, all right, so let me explain that. P is 1.2 e to the -5. That means it's 1.2 times 10 to the -5. A negative exponent moves the decimal 5 left. 5 places left. So I have 1.2, 1, 2, 3, 4, 5. And then you fill in your zeros. So there'll be 4 zeros. So this is 0.00001, 2, and that's our P, and that is less than 0.05, which is our alpha. That's always, we usually use 0.05, which means P low, null goes. And so what that means is it's significant. So when R is significant, let me type. Okay, we can use a line to predict the values. So yes, there's a as we inspect it, it looks like a line. So there is a linear relationship. So since we can see it and it's significant, there's a linear relationship. So if your null is verified, then the value is significant. If the null is rejected, the value is significant. So let's talk more about that. The null is P equal to 0. The alternative, and I'm going a little bit into 6.4, P is not 0. So we want this, since that means if P is not close to 0, that means R is close to 1. So that means if it's significantly different than 0, then there is, if R is close to 1 or -1, R is our correlation coefficient, then it's linear. Then we have a linear relationship. It's a very high correlation. So if you reject the null, it's significant. And that happens when P is less than 0.05. If P is bigger than 0.05, then we keep the null and there's no linear, the linear correlation is not significant. So we want to reject the null. Okay, but again, you get that from that Pearson calculator. Okay, I'll do another example of this because we'll have time to do hopefully one more example. So let me go back and do it the other way. The other way is using the table. You don't have to do it both ways now, okay? Just one. But that was using the Pearson calculator. You should get the same answer no matter what. Using the using the table, using the critical value table. Okay, so here's what we want. We have a number line, and we have a negative critical value, and we have a positive critical value, and those come from the table. If R is here, okay, between those two critical values, you reject. Okay, it's not significant. So you want R to be here or here to be significant. You want it to be at the tail ends. So this kind of ties into all that hypothesis testing, like the two-tailed tests and things like that. We want our correlation coefficient to be outside those critical values, because inside it's not significant. So what we want to do is let me switch to the table just so I can show you how to use the table. It takes a while to come up. Okay, here's the table that I linked to, or that it's linked to in Blackboard. Okay, here's our table. N-2 here is the degrees of freedom. So if you recall, in our problem, we had 11 years. Okay, so what you're going to do in this table, if we had 11 years in our table, we're going to go to 9. 11 minus 2 is 9, so we're right here in this table right here. So our critical value is 0.602. Okay, remember that. So 9, because we have to go degrees of freedom, is 11 minus 2, because we have 11 years. So 11 minus 2 is 9. We look at 9 right here, and we just read it off the table, 0.602. So let me go back to my screen and tell you what we're going to do with that value. Just read it off the table, 0.602. So our critical value is 0.602. Our degrees of freedom was 11 minus 2, which was 9. All right, so we draw a little number line, and we go plus or minus our critical value. And the question is, where's R? Is R in here, or is it outside? Well, R in our problem, if you remember, is 0.9. I'm still doing example 2 in the reading, okay? So R is outside our critical values. That's great. That's what we want. So R is significant. So there's a linear relationship since it's outside. So R is greater than our positive critical value. And it helps if you draw number lines here. And that's all you do to use the table. I mean, I much rather like to use the calculator because it gives you the answer right away, but they're also just teaching you how to do it both ways. But it doesn't matter which way you do it because you still get the same answer. We still got the answer that R is significant. Okay, so is that okay so far? Okay, and then I guess the last part of this, so I want to talk a little, and that, I think, Alicia, you asked me about number 8 in the learning track. That's all you have to do for number 8. It's asking you about the critical value. So, and let me say a little bit more about the critical value. The critical value is beyond which we reject the null hypothesis. So, inside here, the null, you want to find out where the null is rejected. And that would be if it falls outside those critical values. Okay, yeah, if you didn't really understand the hypothesis section, you don't really have to know about all that. All you have to do is make sure that you know how to check if R is significant. And there's 2 ways. You do the Pearson calculator or you do the critical value table. Okay, and then the next question is, what about the year 2050? So that is way outside of our domain because our table ended at 1992. So that's too far to predict. So you could, I mean, you can estimate it, but you can't really depend on that value. So again, you just plug this year into the line, into X. But it's way outside the domain, so you wouldn't really depend on that. And then finally, it's asked you about the slope. The slope is the number in front of the X. So here it's 0.156. Now, if you remember a little bit about algebra, the slope is rise over run, or the change in y over the change in x. So if we rewrite this fraction over 1, then this is the change in x, this is the change in y. So x was years. So this means for every 1 year, the percent increases by 0.1656. Now, if that was a negative number, then the percent or whatever that represented would decrease by that amount. So positive means increase, negative means decrease. So for every 1 year at the bottom, the Y changes by 0.1656. So the percent of, again, this was, let's see, percent of workers paid hourly rates changes by 0.1656. Okay, so that covers that whole example. In example 5, I pretty much covered example 5. Is if they give you R, you just have to look it up in the critical value table and see that it's between the two critical values, so it's not significant. So do you want me to do another example? Or do you have questions on another particular example? Alicia, you asked before I move on, and I guess I'll just do another example. 6.4, you asked about 3, 4, and 5. I'm not going to do those problems, but for 3, 4, and 5, I just want you to know that you only use the second column because it asks for major hurricanes. Okay, so for 6.4 learning check, 3, 4, and 5, you just use the last column. It has 3 columns. It has the decade, it has just the number of hurricanes, and it has the number of major hurricanes. But if you read the problem, it only asks you to find the correlation of major hurricanes, which is the last column. So I hope that helps. And if it doesn't help, ask me again and I'll work that one. Okay, let's go to another example that I just found. Okay, it's not in the book, but I think if we go step through it, let's see, that's not it. Oh, right here. Okay, let's do the same problem. Here's 7, let's do this one, 7 students. I have a SAT score and a GPA. This one I'm going to go through kind of quickly, and I can send you this example so you can work it out. But I'm going to go through it kind of quickly and go through the same steps because it doesn't take too long to work a problem. So we want to find out if there's a correlation between SAT scores and your GPA. And this is only for 7 students. But what I'm going to do is I'm going to copy this table. I just copied those 2 columns because that's what I want to compare. So I press copy. Okay, I'm going to carry it over to Excel. So let me switch to Excel. And let me get a new file. Let's see what happened. I didn't open it. There we go. Okay, new file. I'm going to just pick a cell and I'm going to Control V. Control V is paste. So I insert my SAT scores and my GPA. This is what I want to do. And then I select those 2 columns with my mouse and my finger. So I'm just selecting those columns and I go Insert, Chart, Scatter Plot. Okay, again, I just go Insert, and if your Excel looks different, don't worry about it. You just find your chart. That's the scatter plot. Okay, and then you pick that. So we see that on the x-axis, we have the SAT scores, and on the y-axis, we have GPA. It just automatically does that. It looks linear, so we go to the plus sign. Just click on the plus sign. We want the trend line. It draws it for us. And then we move over to that arrow, and go to more options. Then at the bottom of more options, we display the equation, and we can display r squared. That's coefficient of determination. And we can move those over so we can see them better. Okay, again, so you do that all with the plus sign. Just go to the plus sign, go to trend line, more options. Now don't forget to go to the bottom of that, because what you want is right here. So we displayed the equation of the line and r squared. Now if we want r, we can just come down here, and this is the way I do it. I mean, you can do it any way you want to, and just go square root. So the square root function is the function we want. So you double click on it, or just type it in capital letters. Okay, r squared is 0.8962. So I type that in because that's what I got up here. Okay, so that's how I find r. And that is very close to 1. Okay, so this is my r. That's very close to 1. So this is a positive, strong correlation. Linear correlation, positive and strong, because it's close to 1. Okay, now what I want to do is I'm going to go to my Pearson calculator and see if this is significant. So I'm going to take that value. I'm going to make sure I write it down. Okay, I'm going to write that value down. I'm going to, let me get rid of those. Let me go to my calculator. We go to the Pearson calculator and type it in. So it was 0.946. It'll round to 7 actually. I had how many scores? I had 7 scores. So there's 7 in that chart, and I just go to calculate. So my p-value is low. My p is less than 0.05. The null gets rejected, and it's significant. So we want p low, because that means r is close to 1. Well, we already knew r was close to 1, but we still have to test that. So from the calculator, can you see that p is 0.00122? Now, let's also go to the table, see if we get the same result. So let me switch to the table. This time, the degrees of freedom would be 7 minus 2, which is 5. So we go to row 5, and we find the critical values to be 0.754. Then we just draw a number line and see if our r is outside of that interval. So I'm going to do it both ways, but I just wanted to get you to see you can check the table and you can check the Pearson calculator. Just pick whichever one you want to. Now this is the table inside Blackboard, so it's the same link that you have. So let's go back to the, okay, let me answer a question before I go on. Okay, no questions so far. All right, so using the Pearson calculator, we had r, okay, again, I'm just reviewing, to be 0.9467 with n7. So p came out to be 0.00123, which is less than alpha, which is 0.05. So it's significant. And it looks linear, so we can use the line to predict. If we use the table, again, you don't use both, but you can use one or the other. R, again, was 0.946. 6, 7. Our critical value in the table when we looked up the degrees of freedom was 7 minus 2, which was 5. So our critical value was 0.754. Let's draw a little number line. And we find out that R is over here. R is bigger than that positive critical value, and that's what we want. If it's outside those two critical values on either side, then R is significant. So either way you want to do this is fine. Now, you know, why this calculator works and why the critical values work is way beyond the scope of this book, because as you can see, there's so much material here. But you just learning, you know, what R is and what it tells us, and it tells us that we can use lines to predict. And, you know, instead of just looking at the line and saying, oh, yeah, that looks right, you know, we actually have a test to do all this with. So basically, that's all of Chapter 6 right there. Those are everything that you have to do. You have to be able to find the line in Excel, and Excel does all the work for us, and use the Pearson calculator or the table. And I know some of the problems ask specifically to use the table, but some of those problems give you the numbers, so you just have to decide if R is inside the interval or outside the interval. So again, there's a note in Blackboard, and it says this, and this is very, very important, so I'm just going to read the note. If R is significant and the scatter plot shows linear, it looks like a line. So if you did your test, or one test is all you need. So if you did the test and you find out R is significant and the scatter plot looks like it's a line, then you can use that line for prediction. Okay, you just have to be close to the domain, to the values in the table. It means you can go outside your table and plug those numbers in and get an answer, but you can't go too far. If R is not significant, or it doesn't look like it's a line, then you can't use it to predict. Okay, and that makes sense. I mean, if it's not significant or it doesn't look like it, then you shouldn't be able to use it. Okay, and finally, if R is significant and it shows a linear trend, you may or may not have a reliable prediction outside your domain. So if you go outside the domain, you might not know, because it might be too far away from the table, from the values in your table. So you have to be careful about the prediction. You can always predict inside that domain. Like, so if it jumps from, say, 1990 to 2000, you can use that line to predict 1995, but you may not be able to use that line to predict 2010, because that's outside of 2000. So that's what they're saying in that note, in that example. So I think I answered all the questions I got on email. Let me check. I'll give you a minute to find out if you have anything to say. Let me see if let's see. No, there's no other emails, so I was. That's pretty much all I have. I mean, I guess that we can do another example. Let me know would you want? Is everybody good? We can do another. Okay. All right. Let's do one more. All right. Let's switch. Okay. Let's do this one. 10 quizzes. So we want to know, is there a relationship between quiz 1 and quiz 2? And it says, in the problem it says at the bottom, it says, compute the Pearson correlation coefficient between the scores of the 2 quizzes. Okay, so again, I'm just going to copy. And I think all the tables in your Blackboard, you can just copy and paste. So I just do Control-C to copy it. So I just select what I want to copy, and you can do Control-C, and it copies it. Let's switch to Excel. Let me get a new file. There we go. And I just pick a cell, and I do Control-V, and it pastes it, or you can just do File Paste. You can do, if you look in the left corner, it says Paste. There's my quiz 1 and quiz 2. You can just copy and paste into Excel. I outline the numbers I want to draw, and I do Insert Charts. Go to Charts. I'm up here with the scatter plot. Scatter plot is right here. I just click, and it does my scatter plot. Now that one looks kind of iffy, right? I mean, you could say that there might be a line through those. And here, look, there's 2 values that are the same, two 10s on quiz 1. So the title is not right. It's quiz 1 is at the bottom are the X values, and quiz 2 are the Y values. So this would be a good one to ask about the correlation. So we go to the plus sign, trend line, go to more options, go down. Let's get our line equation, and let's display R squared, and then I'm going to click that on it just to move it. I mean, you don't have to move it, but I like to see it better. I don't know why they put it right on the line, but let me move it more out of the way. And you can also make it bigger. You could just drag, I think. I guess not. I guess not. Okay, so there we are. So we have our slope, we have R squared, and then in this problem I'll explain a little bit. We have time, so I'll explain a little bit more about R squared. So let's come down here in any cell you want, and I'm going to say equal square root of 0.3229. Okay, because if you want to get rid of the squared, you take the square root of both sides. So this is our R value. It's not very close to 1, so there's not really a strong positive correlation. It's about in the middle. So, and we could see that, you know, with these data points outside of the line. So it's not a real strong correlation here between quiz 1 and quiz 2. Okay, I'm going to go back. I'm going to go back to the whiteboard and explain a few more things. Let's see. Okay, so in this problem, we had y equal 0.5996x. Sorry about that extra line there. You can't erase anything on this board except if you erase the whole screen, so that's not good, but anyway. Okay, and we got r squared to be, and today I did not talk about r squared. It doesn't matter whether it's capital or little r. So that's not a strong positive correlation. Let me write down what r squared means, because we haven't talked about r squared. Okay, so I'm going to type this so it's neater. The percentage of variance in the scores of quiz 1, no, sorry, quiz 2, associated with the variance of, in the scores of quiz 1 . Okay, so this is what r squared tells us. When you change r squared to a percentage, it measures the variance between quiz 2 and how it's associated to quiz 1, and that's not very strong. It's only 32.3%. So basically what it's saying is quiz 2 doesn't depend on how they did in quiz 1. It's not a strong relationship. Another way to say this is, let me just type it. Only 32.3% of the variance in quiz 1 is shared with quiz 2. So basically, quiz 1 and quiz 2 don't really have too much to do with one another. That's what r squared means. Now, r just means that there is not a strong linear relationship here. So that's the interpretation of r squared and r. Basically, I covered everything here, but if you find that you're still having trouble in the homework, I hope you see that we're kind of winding down, and I appreciate you joining in, and the finals Saturday already, so don't forget to take the post test also, but you can finish early if you want to. Some have already taken the final, actually. So take your time, finish up strong. and I guess best wishes for the rest of the week. But I'll continue to answer any questions that you have this week. Yes, thank you, Alicia. I hope I answered all your questions. And if I didn't, if you're still having trouble with the same ones, that's okay. Just text me, email me. No worries. I can work those problems out for you and send you the answers that you need. Okay, great. All right, thanks everybody for joining. And again, I recorded it, so if you have any questions about the recording, you can ask me about that too. So have a great day.